Hello, in this video, this is just going to be a quick walkthrough of our basic movement versus animation activity that we've shared within our ADSB Tech Scratch environment. So just to show you right now, I have a clear canvas within my Scratch program, and what I am ultimately going to try to accomplish is create a program where I have two different sprites. And if you are new to the Scratch environment, when I say sprites, I'm talking about the different characters within Scratch. I'll be talking about characters, briefly talking about backdrops, and I'm going to program one to move across the screen and another one will be animating. So again, this is just going to be a quick overview, mostly focused on grade 4 Ontario level curriculum that focuses on creating nested events, but also highlighting quickly what the grade 1, 2, 3 expectations would be as well. So the first thing I'm going to do is get rid of the Scratch Cat right here by clicking the garbage can, and I'm going to start over by choosing a new sprite. And I am going to, for purposes of this activity, scroll down until I find the penguin. There it is right here, this penguin. I'm going to click that once. I'm going to add a second sprite, which is also the same penguin. And there we go. So I have my two sprites selected. Where they are on the screen doesn't quite matter just yet. I'll come back to that momentarily. Now I am going to choose an appropriate backdrop or background. So in the lower right hand corner, I choose a backdrop. And I am going to choose the very first backdrop that's available within the Scratch library, which is the Arctic setting. And I'm going to take my two penguins and drag them down to where I would like them to start on my program. So penguin 1, this one right here, I'm going to start penguin 1 slightly above where penguin 2 is, and I am going to start to do my programming. So right now I'm going to switch over to this area that I'm scrolling on right now, which will be my canvas, and I have a number of different colored bubbles, most of which we will not be using within this particular program. But to start off, to initiate or launch my program, you can see that they have a green flag up here. That is something that we can use as our start. So under events, the yellow coding block, we like to teach students that this is where they can find their events to initiate their programs. I'm literally going to just take the green flag and drag and drop that. Before I go any further, I notice that right now you can see that I am on penguin 2. So penguin 2 is highlighted right here. That means that I am coding penguin 2. That's not actually where I want to start. So this is a good teachable moment. Make sure that we are coding the correct sprite. So I want to be coding the very first penguin. So let me switch over to the first penguin. You can see that I have nothing on my canvas, but I do need that green flag, so I'm going to drag that over. I can just magnify this a little to make it easier to see. So I have my green flag. The very next thing I want to do is be able to set the location of penguin number 1 so that I never have to do anything like this, drag that penguin over to where I want it to start. I'm looking for my start point to be right here. One of the things we teach students as well, if they are using the Scratch program, that every location on the stage, again, just some vocabulary, this area that I'm hovering on right now, we call that the stage. That's the area where once we click the green flag, the code will start to run. So just to clarify, this is the stage. This area here that I'm now hovering on, that will be our canvas. So what I want to do is switch over to my blue motion blocks. That gives me a number of different options. Even though at the grade 4 level, we don't necessarily talk about our XY coordinates on the Cartesian plane, it's good for students to know that every location of a sprite on the stage is dictated by the X and Y value. As soon as I move my sprite to a particular location, it automatically sets the XY value of that location. There's no guesswork on the part of the students. So my location of penguin number 1 right now is at X negative 199 and the Y value is 13. Again, the only importance that I would recommend for a grade 4 level student or a teacher teaching this right now in the classroom would be just to understand that these XY values refer to the location on the stage where you have the sprite located. So when I click the green flag, right now I can test this out. I'm going to take penguin number 1, drag penguin 1 anywhere, and when I click the green flag, it automatically pulls the penguin back to this XY location. I also want the penguin to be pointed in this direction, actually facing right, because that's ultimately the direction in this program demonstration I'm going to have the penguin move. So we have another block down here that says point and direction. And if you click in the bubble where it says 90, you can see that they have a directional compass built into the program that if you want to change the direction that a sprite is pointing, you can set that within your code. So for me, I'm leaving it pointing in direction 90. The next thing I would like to do is I am going to start to figure out how to code this penguin to move across the screen from the left side of the screen to the right side, and then ultimately I want that penguin to turn around and go back the other way. So now I'm going to start to program my movements. I am going to come up here and I'm going to grab one that says move, and by default it says 10 steps. And again, just to kind of speed this process up, I'm going to show you the way that I would code this. And I'm also going to go to my control block and grab a repeat loop. Now, part of grade 3 curriculum when it comes to coding in mathematics is being able to use repetition, so using repeating events. We are going to repeat a number of steps. Now, 10 steps might seem like a significant number of steps, but in the Scratch environment, 10 steps is a very small movement. And just to show you right now, if I put the 10 steps here and click the green flag, keep a very close eye on this penguin right here, the amount of distance that it will move. That slight movement right there is 10 steps. So what I'm going to do is put that repeat, move 10 steps in a repeat loop. Now I know from prior testing that it is going to, actually what I did is on a previous program I used 6 steps. So let me just change the movement to 6 steps. And I'm going to repeat this 65 times. Now I would never ever show students this code. I would let students try to basically experiment and try to figure out their own number of repetitions. But again, this video is for teaching purposes. So I know from experimentation that repeating 6 steps 65 different times is going to take my penguin very close to the outer edge of this screen. I also know that from experimenting that I am going to need a weight block. So I'm going to grab a weight block under control, and the purpose of the weight block is that when you are coding without using a weight block, sometimes it tends to cause bugs in the program and your movements don't necessarily get highlighted properly and there could be a glitch or a bug in the program. So I'm going to use a weight of 0.02 seconds, and again, this is just for demonstration purposes. When you are teaching this, you can have the students experiment with any different wait times that they want. So right now what I'm going to do is now click the green flag. I am still only coding penguin number 1, so when I click this green flag up here, the only penguin that should move is penguin number 1. And penguin 1 is now starting to move across the screen, and again you can see by repeating 65 times from my prior experimentation, I can see that penguin 1 comes very close to the outer edge. What I want to do right now is be able to take penguin 1 and turn penguin 1 around and have it go back the same way that it came from. So what we would do in class is start to have that conversation. How do we do that? What is the next step in coding that would take that sprite and be able to get it to turn, to go in the other direction? And students might know from looking in the motion block that there is a turn block. So we can take turn, and the direction of the turn, whether it's clockwise or counterclockwise, may or may not be important. That would be important for the students to experiment as well. What I would do now is I would put a turn, and again through conversation try to figure out how many degrees do we need to turn to be able to go back along a straight line. So again, even though this may or may not be your grade level curriculum, it is an opening for a conversation to happen within your math program. So I'm going to turn this 180 degrees. And what we will have students experiment with this, because I'm going to run the program now to show you what is going to happen if we run and turn the penguin around 180 degrees. There the penguin goes, gets to the far side, and it flips upside down on its head. Because the rotation style that it has been set to, and again, we are not going to just come out and tell the students this right away. We want them to struggle and try to figure out what's happening. But what is happening in the Scratch environment is this 180 degrees of rotation is a clockwise or counterclockwise turning around rotation. It's not a left-right rotation style that we think about when we are walking in a 180 degree line. So this will lead to a conversation with students about this other option under motion that says set rotation style left-right. And there are a number of different options where you can not rotate or you rotate all around. So we ultimately want the students to know in a task like this that they are going to need a set rotation style, left-right block. The other question that is going to come into your teaching lessons is, it's one thing to know which coding block to use, but where else do you put it? So for me in this task, I'm going to put it up above, right underneath my point and direction. So automatically, when I click the green flag, I'm going to have that rotation style set. So now when I click the green flag, my program initiates, and I have now turned 180 degrees in a left-right style instead of a clockwise or counterclockwise rotational style. The next thing I need to do is be able to take that penguin and have it move all the way back to where it came from. So I have this code right here, 65 repeats, moving 6 steps at a time, and a very brief wait block. What I can do now, just as a shortcut again, if I right-click on my repeat loop and click duplicate, it saves me the time of having to go and rebuild all of this code. So now if I rejoin that, put my 180 degree turn in, and then join my other repeat, theoretically this should allow the penguin to move across the screen to the right side, turn around, and then go back to where it began. So let me try that. And that's precisely what happened. So that's the first part of this activity. So we have an unused sprite so far that we have not coded, penguin number 2. And again, the goal of this is to start to build in a nested event, which is grade 4 level math curriculum, and showing 2 sprites interacting at the same time, which would be a concurrent event. Now that would be grade 2 level curriculum. So with this being a grade 4 activity, we now need to start coding penguin number 2. So if I click on penguin number 2, I'm ready to start building the code. So for penguin number 2, what I ultimately want to have is penguin number 1 moving across the screen, but I want penguin number 2 to animate. And just to show you what that would look like, I'm also going to show you a shortcut right now of the quickest way to build the code for penguin number 2, because it's going to be very similar to what we are doing with penguin number 1. Let me just get rid of this green flag here and start with a clean slate on my canvas. If I click back to penguin number 1, I have all of this code that is already built. I can click and drag this code. Now this is going to be a shortcut that will save you and your students some time. I can drag it down, and as soon as I hover over penguin 2, you can see right there that that box on penguin 2 starts to vibrate a little. I drop it, and you can see that that code has now been copied into penguin number 2. Let me just magnify that to make that a little bit larger. So now on my screen, I now have a code for penguin 2 that's already built. However, there's a couple of changes I need to make. Number 1, I need to change the location of penguin 2 because penguin 2 is a little bit lower down on the screen. So what I do right now is I don't need this XY value because these coordinates here are not going to be accurate. So let me just drag that apart, and if I come here and drag this one over, you can see that these coordinates are slightly different. So I have a different X and Y value. For it to be aligned exactly in the same X location, I'm just going to change that to negative 199 just to have the same. That's not really important for this activity, to be honest with you. And I now have the exact coordinates of this penguin that I'm hovering on right now. So let me just rejoin this code, click the green flag, and now penguin 2 is starting to move across the screen. So now if I click the green flag, both penguins are going to move across the screen. You can see they are going at the exact same speed. Their movements are identical. They are going across the screen, reaching the right edge, turning 180 degrees and moving back to the other side. The next step in this activity, again, keeping in mind that this is a basic movement versus animation activity, is to build in animation so that the penguin isn't just doing a basic movement. There is no movement with their feet, with their fins. So now I'm going to build in an animation for penguin number 2. So for penguin number 2, when we start to talk about animations, the way to make a sprite animate, if I move to the looks block right here on the left-hand side and switch to the purple looks block, there is a next costume. Costumes we talk to students about, we're not talking about something that you wear, such as a Halloween costume. When we are coding in the Scratch environment, a costume relates to a change in movement, which is going to help us animate. So for example, if I want my very first movement, if I click on Penguin 1 right here again, and I go to Costumes, so up here I've switched from Code to Costumes. You can see that my sprite that I've chosen has 3 different costumes. That's important. In order for a sprite to be able to animate, it needs more than 1 costume. So you can see that I have 3. That means that the sprite that I have chosen will animate. So let me just switch back over to Penguin 2. If I put next costume in my repeat loop, so I'm going to move 6 steps, a brief wait period, just so that the program doesn't bug, and then a next costume. And I can do the same thing down here. Now if I click the green flag, by adding 1 simple coding block, next costume, that will now allow Penguin 2 to animate, and you can see the difference in this movement here. So that's how we create a basic movement with a sprite and an animation within a sprite as well. So just to wrap this up, now we get to the grade 4 content, creating a nested event. So if this is something that is new terminology for you, a quick way to explain this is a nested event in this example would be a repeat loop inside another repeat loop. So we have a repeat of 65 repeats of 6 steps at a time for the penguin to go from the left edge to the right edge. We are repeating those exact same movements a second time for the penguin to go from the right edge to the left edge. So we have some code here that we don't really need. Another way of saying this is this movement, let me just break apart the second set of repeats. Now this section here that I'm hovering on and circling with my cursor, those movements are actually repeated twice. The first set of repeats is going to be the penguin moving from the left to the right, but then all of these steps are being repeated 1 more time to go from the right edge to the left edge. So what I can actually do is move to Control, grab another repeat, change that to 2, because this set of movements right here is repeating twice. If I drop my repeat loop inside another repeat loop, I have now created a nested event. So my code is more efficient, which is where we start to get into grade 6 level coding, talking about efficiency. But instead of using the same repeat block twice, meaning this, I can now just repeat it in a second repeat loop twice, and my code will look like this. I don't need this, so I'm going to drag it over here and drop it. I can get rid of that. And now, when I press the green flag, it doesn't change my code. My animation and basic movement program is still running, but I have created a nested event with this code for Penguin 2 by putting the repeat loop, my initial repeat of 65 times, and saying that I'm doing this twice by putting it in another repeat. So I've created a nested event, which is grade 4 curriculum. I hope this video has been helpful for you. Thank you.